Okay, I want to cover the discussion section of your investigation. That's the last 2 pages. Why? Because I'm a senior maths teacher, okay? In SACE, you have to talk about these things called assumptions and limitations. Your teachers last year, no issue with them, but they didn't teach senior maths. So they don't know where it's leading up to. They may have given you a little hint about it, but I want it from the horse's mouth because I teach senior maths. So in every maths investigation you do from now until the end of SACE, you're expected to write about the assumptions and limitations behind the maths modelling you've done. Why? This is because in all of these, you're using maths to model a real life situation. Do you agree? Is that what we've done here? But you need to show there's some understanding. There's many factors in real life that might affect that model. Okay? It is not perfect. The last 2 pages, your projectile motion investigation, are dedicated to assumptions and limitations behind the model. So can you tell me, what did we do in this investigation? What kind of equation did we use to model a throw? Starts with a Q. Quadratic. Used quadratic equation to model a throw. How did we actually make that equation? What was the only thing that we measured? The time of the throw. Found throw time. What results did we present? Well, if you're up to it, you're just doing 2 graphs. They should pretty much be about the same. The only difference is slightly different rounding, okay? This graph is what your results will look like. You're making the assumption that you threw from 0, 0. You're telling me whatever your flight time was where it landed in the x-axis, and it landed, so y is 0. And then how did you decide where the vertex was? Halfway, right? So you got all this information from your one throw. So based on these 2 graphs that we drew, does that mean that those graphs perfectly represent the flight of the ball that we threw? Yes or no? No. I'm glad you agree. No. Why not? So the why not is what your assumptions and limitations will be about. It's never going to be a perfect representation because you made a number of assumptions and there's many limitations behind what we did to make it work for the quadratic equation at year 10 level maths. We don't do hard enough maths to have a throw that looks like that. Writing about these makes you feel like you're criticizing your work. That's exactly the point. Because you're trying to show that you know that is not actually what happened. It's close. Do you agree that it would kind of be close? But it's not actually what happened because there's more to it than that. Wind resistance. Okay? So really what you have to be aware of is when you're writing, in those last 2 pages, when you write up an assumption and limitation, tell me what it was and tell me how it affects the accuracy of your results. There's 2 parts to it, but you need to write it into a paragraph. So let's do an example. This is a gimme, okay? This is the result that we presented. What does that say about where we threw it and where we caught it? Are they exactly level? Yes? Is there anyone here that's perfectly the same height? Is there anyone here that caught it at exactly the same level? See? We made an assumption that it was caught at the same level. So how would I write about that? Assumption that a throw released at same level as catch. We have to assume that because why? Because our quadratics has to have the same x intercepts at the same level. How would that affect our results? You tell me. If you can't think of that, what if we showed this? What if I drew the person here a certain height and then let's say the person that caught it was shorter? If it was caught lower than when it was released, what does that do to the flight time? Is it a longer flight or is it a shorter flight? If it's a longer flight, okay? What's that going to affect the result? That means that your graph is going to actually land a bit further than it should be. Does that make sense, how we had to make that assumption? Because we're only doing year 10 maths, so it has to be perfect. But it wasn't freaking perfect, was it? You're not exactly at the same level, okay? So throw at the same level as catch. This would affect the results because what example did we do? If the catcher was shorter, the flight time would be, what did you say? Longer. Flight time would be too long. Conversely, would it work the opposite way if the catcher was too tall? See? And then your perfect thing would be a little short. It wouldn't be right. Okay? That's an example of an assumption. What's a limitation? Let's call back to how you generated your equations to produce the graphs. You timed the flight of a thrown ball. Are you perfect? Is there an accuracy in that time? Is there an accuracy in your ability to press that button when it was thrown, exactly when it was released and when you caught it? Yeah. So if you were delayed in pressing the end, would your time be longer? That would give you the wrong impression and your quadratic would land further out than it probably did, okay? If you timed it and you pressed it a little early, then your quadratic would land a little shorter than it should have, right? I won't write that out because my writing's garbage while standing here. But do you see how you're almost criticizing the work, but it's showing your understanding, okay? Was the ground perfectly level? Would that have affected it? Is there something wrong with this model? This model is symmetrical. Is there air out there? Would the flight have been symmetrical if there's air particles in the way? It probably would have been shaped more like that. So flattened on the other side of the vertex, okay? Hammer that. That little box at the end here, fill it up with as much as you can without repeating yourself. Because that's what you're going to be asked to do in year 11 and year 12, okay? Anything you can ask me if it's a reasonable, just ask me. Yep, I'll be like, yes. You decide how you'll write it up there, okay? You don't need maths for that. So if you want to have a break from the maths grind, go to the end page, get marks writing these up, all right? I'm going to go over to their class and deliver that same lesson, all right? But yeah, if you got questions, just chuck your hand up. And that's it.